Today I will be going over derivatives of inverse trig functions, and in our case we'll be going over the derivative of the inverse cosine function. Alright, so once again there's two types of formulas we can use. My go-to formula is this one. So it's basically the when dealing with the derivative of inverse cosine, it's going to be it's going to be the negative u prime divided by the square root of 1 minus u squared. This is my go-to formula. This is what I use. But you can also use this formula, which is the most common one. It's basically negative 1 divided by the square root of 1 minus x squared. I like this formula better because I get to break u down and I just insert u prime and u into the function and I get my answer. But you can use this one as well. Um, I'll I'll be I'll be proving this one later in the video. All right, so let's start with a example so we can understand how this formula works. All right, so when we have the function um, y is equal to the inverse cosine of 2x, what do? What I like to do is use this formula once again, and this formula relies on u. So in our case, what's our u? It's 2x, right? So we put that down, right? We have one half of the formula set. We have our u. What's the next half? We want to get u prime. So what is the derivative of 2x, guys? 2. All right. Now we have our u prime value. We have our u value. What do? We just go back and insert it into this formula. All right. Boom. Now the numerator u prime is going to be negative 2. The denominator 1, which is the square root of 1 minus u squared, is going to be 1. It's going to be square root of 1 minus 2x squared. But that usually doesn't look good, and I think most math professors would want you to simplify it a little bit further. So you would just square the 2x, and you would get this. So this is the actual answer. It's negative 2 divided by the square root of 1 minus 4x squared. So that's an example of how you would solve a example of an inverse cosine problem. So now let's actually prove why this formula works. I'm going to use the other formula to prove it. Okay. All right. Let's prove why the derivative of inverse cosine usually falls in the category of this formula, negative 1 divided by square root of 1 minus x squared. All right. Start off. Y is equal to cosine, inverse cosine of x. First thing first, we want to solve for y, right? We want to get the derivative of y, which is the derivative of cosine. So what I like to do is take cosine on both sides. So this would cancel this cosine out, and we'll add a cosine over here. So now we're left with cosine of y is equal to x. Next thing what we're going to do is we're just going to take the derivative with respect to x. If we take a derivative with x, the derivative of x is going to be 1. But the derivative cosine is going to be negative sign. And because we're doing it with respect to x, we have to take the derivative of the y component, which is going to be y prime. And this is what we're trying to solve for, right? Y prime is the derivative of the inverse cosine function. So we just do algebraic manipulation, and we figure out that the formula is negative 1 divided by sine of y. But we derive the formula, but it does not look nothing like this. Why isn't it looking like this? We'll take it a step further and prove why it is. But essentially, these two things are the same thing. All right. If we make a right triangle and we show how this right triangle would look, y is going to be the angle, right? And if we manipulate the variable, we can see that the x is going to be the adjacent component, and the 1 is going to be the hypotenuse. And through Pythagorean theorem, we can solve for the opposite side, which is going to be the square root of 1 minus x squared. So, going back, sine is equal to opposite of a hypotenuse, right? And what we concluded was this. Derivative of y is equal to negative 1 sine. So, if we want to make, if we want to put values in this equation derived, we just use information we found from our right triangle. And the information we found on right triangle is opposite over hypotenuse using sine. Remember, sine is opposite over hypotenuse. And we just insert that information into this information, and voila, we have our formula.